Hey, good morning, good afternoon, or good evening, everybody, and welcome to another episode of Game Day Essentials. I am Scott Ward, Solution Architect from Amazon Web Services, and I'm joined by
Joe Fontes, Solutions Architect, Amazon Web Services, and we are live from New York City. Woo!
Yes, good afternoon, everybody. We are not at our normal AWS location as we've done our last few episodes. We're actually coming to you from the AWS offices in New York today due to some travel and some summit work yesterday. So good to see everybody and have everybody out there today. And once again, thank you for joining us as part of this great event. We're going to start off with talking about kind of what is game day and kind of set the stage for everybody who's participating and maybe seeing this for the first time. So if we start off with, game day is basically this really, really cool event that we've created that we are, we've been running at our AWS kind of public events as well as some private events. And to set the stage for what game day is we're focused on, it's really your first day on the job at a company called Unicorn Rentals. It's a fictitious company that we've created. It's your first day on the job. Unfortunately, the team that built an application that you're supporting is no longer actually working at Unicorn Rentals. So you are responsible for not only supporting the application, but figuring out how that application works and how you would actually architect it. You've got limited information about the application that you're supporting, but unfortunately you're supporting traffic. We have a wonderful scoreboard that's tracking your progress and your team's progress. So you have a little bit of pressure on being able to accrue points. You have to learn how to work as a team. We often put you as a team with people that you don't know. You've got a really crazy run book, which I've been able to highlight in the past, that's got some questionable information and probably resembles a lot of run books that we've seen in the past on past jobs. You've got an AWS account that's supporting the application, and you've got to figure out what's in that account and what's appropriate and what's relevant for your architecture. You need to evolve it over the day, react to external and internal events that will impact your architecture and adjust your architecture based on those events. So it's a really awesome adventure with some live hands-on work with the AWS account and the services in AWS. So that's what Game Day is a real quick summary and kind of helps everybody understand what that event is like and what you might be experiencing. So last week on our episode, I was not present, but Joe and Dave were on it, and we talked about a few specific things. And I'd like to, Joe, if we could just kind of briefly recap.
Yeah,
what was
absolutely.
it like last week?
Yeah, well, I mean, first of all, it was a little bit difficult since you abandoned us. Again, so I'm getting used to this idea of abandonment here.
Well,
Dave's not here this time. I'm kind of like the 8th stand-in that keeps showing up. And pretty soon I'm actually going to have been in more episodes than you and Dave. So I'm feeling pretty good about that. Last week we made fun of Scott for a little bit for not being here. And then after that, we kind of got to work a little bit. We talked to the community. We went through, what are some of the logging solutions you're using now? Kind of built off the conversation of what are the anticipated and unanticipated changes that you see within an environment. Our anticipated changes, as Scott and I had talked about a couple episodes ago, things like auto-scaling, and then how do we even find out about unanticipated changes? So if something breaks, how likely are you to be familiar with it or aware that it's actually breaking? And so we went through, what's everybody else using? We had some really good examples. The Elk stack was popular. We had a lot of individuals using, CloudWatch logs. We saw a really great publication about implementing CloudWatch logs with PHP monologue. Yes, that's right, Scott. That is my publication. Wow, what a coincidence! And apparently there are some other publications as well that we didn't go into. But kind of looking at some of the classic solutions as well. syslog-ng, our syslog. What are we doing with like Cisco and networking logs? Mm-hmm. How are we ingesting it? We talked about some partner solutions, things like Splunk. The idea of, do you really want to build a homegrown solution? Do you want to, utilize, a solution that already puts into practice, basic statistical analysis, things like anomaly detection? And so it was really good. We had some really fun examples from the polls. Individuals still using grep. I defended grep a little bit as far as log parsing, just because she's been good to me. Yeah. You just got to split the logs a little bit and it's all right.
Grep can be your friend in a pinch.
Yeah, absolutely.
Cool. Awesome. Well, it sounds like it was a good episode last week, and it sounds like some people got some really good value. Glad to see that we've got some people on and watching the episode today. Feel free to throw your questions or chat messages into the chat box. We'll be asking you guys some questions in a little bit and looking for your feedback as well. So hold on tight here, and we'll get started talking about what we're going to really focus on this week. This week we're really kind of trying to put our focus around the concept of decoupling and what does decoupling mean when it comes to architectures and architectures on AWS a little bit more specifically. So we'll be diving deep into that and talking about different ways that you could approach the concept of decoupling. We'll try and tie it back to some architectures that we'll have as a starting point. And we'll be looking to you guys out in the audience for some feedback on ways that you'd like to do things or approaches that you've seen that you might be able to take when it comes to decoupling. So with that said, let's go ahead and talk about what our starting point is here. So we've got an initial starting architecture that Joe's going to bring up for us for here. That's basically a simple starting point, and this is our message collection and assembly architecture. And I'm sure a lot of people will look at this right away and say, "Wow, that looks a little bit light and maybe not ideal." But in this concept, we have a message collection service. It's receiving messages via HTTP. Each message that we're receiving contains part of an overall message. So no one message has all the information that we need. The message gives us some indicators not only of its content, but which part it's in. Our application is currently storing all those messages in memory. And then once all the parts have been received, so we get an indicator that it's maybe part 2 of 2 or part 10 of 10, all the parts are then assembled, pulled out of memory, assembled back together in the appropriate order, and they're sent back to the final message consumer. So that's our application that we're working with as a starting point. And so I took the liberty of, we had our discussion a couple weeks ago about kind of high availability and durability, and I went and kind of assembled our architecture one level deeper. So if we go there's the next PDF, Joe. I actually took a stab at doing some of the things we talked about. So I actually created an application load balancer that's balancing to multiple EC2 instances in different availability zones. And those EC2 instances are still sending the information back out to that final message consumer. So I felt pretty good about having that availability. But as I was actually running my application, I quickly realized a couple of things that we're going to discuss now here, is that my application actually wasn't sending very many messages out because it was never really able to find all the completed messages. I also found that at times when my EC2 instances would need to be replaced due to issues with the underlying hardware, that I would lose all the messages that were in memory. So while this was a good approach for availability, there's some definite issues there as far as kind of tightly coupled components that are really impacting my application. So that really brings us to kind of talking about decoupling and some of the challenges you might have with that type of an architecture. So before we get started in that, I just want to give everybody a quick reminder. You are watching Game Day Essentials today. This is our broadcast where we talk about AWS Game Day and some of the challenges and things you might see and ways you can approach things. When we start about challenges with architecture and decoupling, Joe, give us a couple minutes and talk about what does decoupling mean to you at a high level in general?
Yeah, sure. So when I think of decoupling, I kind of think of the first time that I performed this task, being able to break up services a little bit in order to kind of tweak the underlying infrastructure. So, if you think about it, this is kind of the, Unix type of philosophy, which is, you need individual services to handle individual aspects of a service, of an offering, and being able to tweak those independently to improve availability, performance. And when I think of the very first time that I had to kind of decouple a project, this actually might be pretty familiar to those watching, because I think it's everybody's, well, not everybody, but I think it's a good portion of the first experience, and it's with something similar to like the lamp stack, for instance. I remember one of the first gigs I got in college. I had to put together a website and an entire infrastructure for an internal application. And so, just like everybody else, I deployed your standard LAMP stack. And this was all on one server at the time, long before AWS. And so you had Linux, Apache, MySQL, PHP, and so they're all running on the same box, and that doesn't really scale. If you want to set it up for high availability, you need a whole separate clone on the other side. Right. You've got to replicate your scripts, your files, your data, and you're not scaling the individual components. If your database is running hot, and you create a bunch of read replicas, for instance, you're scaling the rest of the infrastructure too. Not every server needs to be a load balancer. Not every server needs to be a database server. And being able to decouple a lot of these services, put Apache out on its own set of on its own layer, put maybe a load balancer in front of it, have the load balancer handle things like DOS attacks, act like an application firewall, really pulling the application apart piece by piece. And I think it's going to be a common concept that we hear from individuals, just because it's one of those obvious first steps since it's such a large style of deployment. But I mean, you're going to see it with IIS, you're going to see it with Microsoft SQL Server. Maybe initially you're running them both on the same box, and probably break them out later. And so there's a ton of other examples. I worked heavily in healthcare, breaking those applications out so that the areas that are just so CPU and IO intensive, we can really focus those across multiple machines and move off the other items that maybe don't draw as large of resources, and be able to set up those for high availability.
Right. I remember the first time I learned about decoupling in a previous job. It was pretty eye-opening to be able to realize that you could build things so that different components can survive and grab different resources and not impact the overall application or the service that you were running. So it's a pretty eye-opening thing for me as well. And I think it's there's a lot of ways to do that on AWS. When we look at this specific architecture, one of the things we'll probably be looking to really do here and talk about in a minute is how do we take that memory store. In my example, I said we're storing all these messages in memory on these EC2 instances, and we've unfortunately put ourselves in a position where the messages are going to different instances through a load balancer, which we want, but the different parts of the messages are now on different EC2 instances. So how do we resolve that? By decoupling that storage of the message information out of those EC2 instances and maybe into a different data store.
So Scott, just to make sure everybody's familiar with what we're talking about as far as all these message segments, we have an example here at the bottom. So what we have in the left column is an ID for the message. And then what segment it is. So if you kind of follow the bouncing ball here, everything in 101, you'll have segment 1, 2, 3, 4, 5. So the sentence that this forms once you put all the segments together is hello and welcome to AWS Gameday Essentials.
Right.
If you have what is it? If you have 6 out of 7 segments, the message isn't going to make any sense. If you put it together out of order, it's not going to make any sense. If it's just hello and to AWS Gameday. So you need all of those segments. So, what Scott is saying is, what if segments 1 through 5 ended up on one server and segments, 6 through 8, 6 through 7 ended up on a separate server? You're not going to be able to assemble all of those. So, this is my attempt at putting together a pretty diagram.
Cool. We're gonna talk about some specific examples that we had around kind of decoupling state, but for the audience and the people who are watching today, I'd love to get your feedback. If you could put it in the chat, what are some ways that you would think about how you would decouple, and kind of leveraging the existing architecture we have? What are some services or approaches you might take to kind of decouple that storage and put it in maybe a different spot, or enable the application itself to kind of be able to scale out and actually run highly available while still being able to kind of maintain and store that state? Throw your ideas out there. We'll talk about them in a couple minutes. In the meantime, Joe, I think you wanted to talk about a couple of specific examples you and I had talked about that you had around ways we would use AWS services specifically to kind of decouple the state and kind of change our architecture. So can you talk us through a couple of those?
Sure. It's so we have all these messages coming in, right? And we have a few different opportunities on how we act with those services. I mean, later on we could talk about a few of the more advanced concepts that we kind of kicked around earlier. But, it doesn't matter if, these are individual messages we're trying to assemble them like the segments we have here. It doesn't matter if it's somebody signing up for a rental car or if it's a web application. The important part is that, your application gets the information that it needs. And so if we have all of this information coming in and it's spread across all of these application servers, and it could be, hundreds, the question is, where do you want to store it? So what if we, the easiest thing, that probably comes to mind is I want to store it in the file system, right? So now we have, let's say our web application writes to, where did I put it? Storage, yeah. So let's say it writes to your local EBS volume. And so in this example, we have one instance that, yes, it received all of the messages. But what if we have a second instance that only received half of the messages? At this point, we have to think about, are we putting together logic to actually synchronize all of these files across, both of these instances?
That sounds like more of a problem than it's going to solve.
Yeah, absolutely. And where else have we seen a similar type of outcome? Maybe something like web application session storage. And I mean that's Java, that's PHP, that's every web app that you're putting together. It's going to have some kind of session storage.
Exactly. Yep.
And so, probably not ideal. I don't want to sync, hundreds of thousands or millions of files across all of these locations. So one option, if we're talking specifically about the web application, let's see, what is the symbol? Here we go. So we could put them in S3. And so using S3, so first we've got, if we want to assemble them, local. So we're assembling message 1, that's from the local file system. And now if we want to assemble the messages from S3, we can also cat those messages to the command line. It looks a little bit slow, but that's because my script is horrible. But if you have a centralized location such as S3, you're no longer having to store any of this information on any of your instances. So we go back to this idea of let's treat instances like cattle instead of pets. So if all this is stored in S3, I don't care what happens to this instance, because whatever auto scales up is going to take the place of this. It's going to access that centralized repository, and we're going to be all set.
That's awesome.
Have you, out of curiosity, have you had any examples of where you've migrated maybe traditional storage or a traditional solution to S3?
I've seen some use cases where I've seen customers or partners that have content management systems where maybe it's instead of having to store all the content on every server that needs it, or even using an NFS mount file share, that by going to S3 they get to take advantage of the availability and durability that S3 gives, and allow to just kind of like completely shift the storage into S3 and away from things that they're normally using maybe a traditional file share for. So I've definitely seen a few use cases where S3 has kind of become that centralized point for storage.
Yeah, and that's funny that you mentioned that. I was trying to think of some kind of popular examples, and then it hit me. We just saw a WordPress S3 plugin. Okay. We saw a Joomla S3 plugin. And then working with our storage partners, I can't believe I forgot that. Instead of having to worry about where are my backups stored, where are all these essential files that we need if something happens. Right. Instead of having to check, if this let's say it's on DFS for instance. Right. What's the backend block device for that DFS instance? Are you keeping an eye on it? Are you monitoring it? Is that being replicated to other locations? Instead, if you just put it on S3, and we've seen storage partners be very successful with that type of solution. Very cool.
Very cool. So I'm going to shift our order a little bit if it doesn't mess you up too much. One of our participants, PL and SF, talked about using Redis in the last game day to store messages. And I know you and I had talked about Elasticache a little bit. That's another option. You could kind of use some sort of a caching solution to kind of decouple this type of storage. So tell me about what you were thinking in that sense.
Well, so we don't have a poll set up for this, but I imagine there might be a mighty flame war if we put in the question Redis or Memcached. Just know that I play fair with every caching solution, so I'm more than happy with either one. But we did set up, just as an example here, we have a Redis individual node setup. And so it operates in the same way. So, let's say we've got just billions of messages that we're storing in our database, and it's read intensive, and we've read, message 1001. We've read it, we're reading it every 5 seconds. Let's stop throwing that query at the database. Let's put it at an in-memory solution.
Right.
And if you look at, where are the places that you're seeing Memcache and Redis, when you think it's like, oh, okay, well, I've seen it with the LAMP stack, or I've seen it with session storage. Where are the places that you haven't seen it? There's really cool solutions out there. If you're looking at something like Couchbase with in-memory databases designed along with persistent storage solutions, just that combination of performance and throughput, having the hot spots as far as, what data do we need to query fast. There's some really cool stuff going on.
Yeah. I mean, I've seen Redis. I've been doing some recent education on Redis and found it's actually quite a popular key value store.
Yeah.
When you hear caching, certainly it gives you fast access to data, but just even storing your data in general, or as another spot outside of your normal data store, it can certainly serve a lot of purposes to kind of, once again, decouple and move things away into its own tier that can scale and have its own availability and durability that's specific to the data. So yeah, I think Redis is another great option, or Elasticache in general.
Yeah.
What about, so I come from a relational database background. I love relational databases still. I think there's still a great place for them. Would relational database be a good place where I could kind of decouple the storage for this type of solution as well?
Sure. And it's probably one of the more common solutions.
Okay.
Maybe, originally we were seeing, this was back when, I don't even know what year it was. I don't know. Originally, we saw a lot of maybe block storage for data that really should have been in some form of database, relational or, object or some kind of database. But, recently, as, I've seen across the past 10 years, when you have some kind of data storage requirement with an application, I'm seeing right out of the box, individuals are going with a relational database. More predominantly now, it's kind of that mix between NoSQL and SQL. But, 5+ years ago, it would just kind of be a default. You go to start building your application and you're going with Postgre or MySQL or MariaDB or, Microsoft SQL. You're just kind of going with it out of the box, even if it's a smaller database storage requirement that could be done in the block space. I'm just seeing it just because everybody kind of got so used to it. So I mean, yeah, my first thing that I always draw upon when I'm storing data, whether or not I need to store it in a relational database, it's just habit at this point.
Yeah,
I just fire up a MySQL server.
That's cool. Yeah, I mean, and the cool thing with with MySQL or any relational database solution in general, and even more specifically with RDS, is that you're going to be able to get the ability to have a highly available architecture because you can run across multiple availability zones. You get the automatic backups. You get the ability to make snapshots. So you have the ability to kind of really protect your data and make sure that it's always available for your applications, so that your application tier can kind of flex up and down horizontally and still be able to always access your database tier, whether there's a failover or not. And RDS even gives you some really cool options to be able to vertically scale your database with little to no downtime if you're running in that multi-AZ architecture. So it's a pretty cool option as well.
Yeah, I didn't feel like our example here needed multi-AZ.
Yeah, I think so.
I'm going with frugality here. So just like the Redis cluster, we're going to pretend that I set it up in multi-AZ.
Okay,
cool. Burn through all my credits.
Cool. While we're talking, for the people in the audience, I'm putting another poll into the chat. We'd love to know a little bit about what kind of centralized storage solutions you're using or you've been using in your jobs today. There's lots of options. I've thrown some AWS stuff in there. I've thrown some non-AWS stuff in there. Different options. We'd love to kind of see what you guys are using there. Now, there's a couple other things I put on this poll. So certainly DynamoDB that's just another key value store at the end of the day. Has its own kind of managed availability.
It's something that I do want to add, though. I'm not sure if everybody's aware of it, but actually, it's really cool. You can store JSON directly into DynamoDB and then query it specifically.
Yep.
And that's a feature that I've just really kind of fallen in love with. I have extremely complex JSON structures, so I don't want to have to worry about parsing these things out. Is there a value that's not present?
Right.
And so just being able to kind of shove it into DynamoDB has really made my life a lot easier.
Okay, that's very cool. Did we talk about HTTP versus kind of data caching yet?
We did not. During the poll, though, I would like to highlight some of the amazing prizes that you can have at AWS Gameday. Joe here is modeling a unicorn bracelet that could be yours should you win. Whoa, look at all these stickers. They're amazing. You too could have one of these stickers. And they're not all free. Oh, yeah, they are.
So when we talk about kind of the data storing, we've talked about the word caching a few times. I think it's important to kind of note the difference between maybe data caching and HTTP caching.
Yep.
There's some different things, and do you mind kind of talking through that for a minute? I'm actually going to draw a couple architectures on that diagram that kind of represent what we've evolved to. But can you help our audience understand that the difference there on those two types of approaches?
Sure. So, those in the audience, you might be familiar with the terminology for CDN. When we look at caching, there's really two specific types that kind of create these broad areas. So one is we're caching information that's typically going to be the same for most of the time, and then we're caching information that's going to be pretty dynamic and is going to change relatively often. And so when you have something like AWS CloudFront, which is an HTTP cache, that's really ideal for items that aren't going to change that often. So for instance, let's say my LinkedIn profile picture. That's probably going to be the same until I change it, which is maybe twice a year. And so that's a great piece of information to cache at edged locations. Since if I change it twice a year, the second that I put up a new one, you could actually invalidate the cache across different locations, but it's not something that needs to be updated immediately. It's not going to be like, your physician scheduling or, your credit card statement that has to reflect constant information. And so, being able to deliver that to end users as quickly as possible, it's information that doesn't change very often. That's been the responsibility of services like AWS CloudFront, as well as other CDN providers. Kind of moving a little bit back, a lot of times, if you're running your own infrastructure, you may actually build your own HTTP cache. Right now, the popular solution is Varnish. I've always been more of a Squid person. As I understand, Varnish has done some amazing things. It's just kind of set in the old ways. And so you could build your own HTTP solution. You can go with a service. Really, there's a lot of different opportunities, especially with AWS CloudFront. And so that's for the content that stays static. Now we have, let's say you're doing a rental car purchase. You're renting a car, for instance. That information will change and will be updated relatively often. So for that, you're going to want to use a data caching solution. And just as we saw with the question, Redis, Memcache, any kind of database caching solution is going to be this middle layer between the application and the end database, and it kind of moves some of that load off of the database. If you have an application that's really read heavy, one option is just create a bunch of replica servers. You can query those individual replica servers, but if this data is being queried relatively often and you have an idea that it's going to be necessary again, it's going to be great to have that in memory. Let's call that up as quick as possible. Let's not even tell this an instance that it needs to go to disk or something like this.
Very cool. Very cool. So we have had some people respond to our poll about centralized storage solutions, and a relational database is a clear winner at this point. We do have people that have chosen something else, so I'd be curious on what that something else is. If you're bold enough to share that with us in the chat window, we'd be interested to know what that something else really is. because certainly, we put a lot in there, but love to know what those other things might be.
Yeah, I'm really curious about that. I thought we covered some of the top.
NFS.
Oh,
of course. So NFS, the Elastic File System, if you're looking at AWS or any sort of an NFS mount to a shared file storage, certainly would be an option as well. So if we take a look here, I don't know if the camera can pan over and see our whiteboard for just a moment here, but if it can, I don't think it will. We've altered our architecture at the end of the day. We've taken and split the storage part of our messages away from the application stack. So if we go back to the architecture that we had up, we've taken the storage component and split it out. And I've represented it. You can't see it on the drawing here, but it's in a cloud. It's got just various storage options. So we've got something that is taking the message and shoving it into a centralized data store. And then we would have some sort of job that, whether it be running on these existing application instances or some sort of a background job, could be a scheduled Lambda job, could be cron job, that's then going and looking for all the messages and pulling them out of that data store and finally sending it back to our final message consumer. So, with what we have, we've arrived at a kind of a cooler architecture or a more durable architecture, and it's probably supportable and it can scale a lot more on its own at the end of the day. But I'd like to, two things. One, I'd like to ask the audience, if we had a chance to completely re-architect this solution, keeping in mind that we still need to support receiving messages in parts, storing those parts, collecting those parts, and sending them back to some other final message consumer. If you had the ability to kind of re-architect this entire thing, what are some ideas that you would have? Are there some different AWS services you would think about using or ways you would do it? I'm going to give you guys a couple minutes. I'd love to see what you guys think, and we have some ideas that we'll talk about as well. But take a minute as the audience. What ideas do you have? And while we're going through that, just want to kind of give everybody a quick reminder. You are watching AWS Game Day Essentials, where we talk to you about concepts and ideas that you might experience while you're going through an AWS Game Day event, and ways that you can approach that and look at those things.
A reminder that we are live from New York.
Yes, we are.
I know. Well, so it's tough, with this amazing view, it's kind of difficult to tell that we are in New York.
Yes.
But, man, it's good to be back. It's been a while since I've been out here.
Yeah, it's been a while for me, too.
Yeah, this is my alma mater's out here.
Okay.
Marist College, Poughkeepsie.
Okay.
So I was an hour and a half outside of the city, and I've been here more with AWS than I did when I went to school. It's kind of ironic.
Yes, that is very ironic.
Just kind of looking at the screen here, I'm not sure, for those who may not be familiar with AWS RDS, just as an opportunity to check in, if you look, the screen here on the right is standard MySQL deployed locally. Screen on the left is MariaDB on RDS. It doesn't matter if it was MySQL. This operates in the same manner as a standard MySQL deployment. The only difference is that you don't have to worry about backing up the database. That's something that's handled when you create it within the dashboard. You can set up tasks such as it should be backed up ever so often. Apply updates on this schedule. This is when I can allow downtime. That type of thing. So really, kind of getting you out of the practice of reinventing the wheel every time you deploy your own solution. There's some great there's some really cool projects that make it much easier on AWS to scale and set up high availability with MySQL, even outside of RDS. Something like, I think it was Galera is a great one that's been highlighted pretty often. So there's definitely a bunch of other opportunities out there, but RDS really works hard to make it as easy and seamless as possible.
Yeah, I would agree. All right, so our audience is a little bit shy today, but we're going to take some time and talk through what are some ways that we would completely reinvent the architecture we talked about today, as far as being able to receive messages, store them, and assemble them and send them back while still maintaining availability in a pretty well decoupled approach. And the first thing that comes to mind for me when I'm looking at architecture patterns and ways that we might do that is, what could I do to maybe remove that EC2 instance entirely? And so, serverless is one of the hot topics and terms right now that gets used a lot. And I can envision an architecture where maybe we replace our EC2 instances with a Lambda function because the purpose of that Lambda function now is just to receive the message and store it somewhere. Yep. So we could potentially remove the EC2 instances entirely from our architecture. Probably put it behind something like API gateway, maybe.
Yeah, that sounds really good. I think the bigger question is what language would you use in Lambda?
Well, if it supported PL SQL, I would do it in that, but that's where my background is a lot. But definitely, I'd probably Python is the one I'm learning right now. But as long as it's not PHP, I'm okay. We got some Java persons here too, and we actually have somebody who's chimed in about using Lambda and Dynamo as far as re-architecting that as well. So certainly, having a Lambda function behind API gateway, and then Lambda functions and then writing to the Dynamo database. So it's like, hey, here's a message, here it is, it's done. And then you could probably go with a Lambda job to reassemble those messages and send them out, something that's maybe on a scheduled basis, and looking for completed messages, or if there's some sort of a tickler in that message that says I've given you the last part, you could kick off a job that's looking for the parts. I think there's several ways you could go around that, and I think that middle, the bottom is that middle part that's EC2 can get replaced with Lambda. A couple other services that come to mind for me are, one is SQS. I mean, it's queuing, it's messages, right? We're receiving messages, right? Would you see SQS kind of factoring into an architecture like that?
Yeah, absolutely, and it lends itself so well to this type of solution. It's the one of the original AWS services. It's been in use for a long time. It's tried and true. It's tested, and it for those that have maybe not tried it out, if you utilize the AWS SDK, especially, you could pick whatever language you're using against it. But I look at SQS as a standard solution for this type of solution. But what I'm kind of curious about is there's as I think about this type of problem, there's so many ways to solve this on AWS. Using serverless. I guess one of my favorite events to kind of follow is the C obfuscation. I think it's a game or something. Anyways, every year or so, they try to create the most obfuscated C program you could think of. And it's really interesting the way that they do it. And so I'm wondering if we should create, the most obfuscated way to accomplish this on AWS. Yeah. I mean, how many services can we link together to do this? And, off the top of my head, I'm thinking, AWS IoT with MQTT. We could have a Raspberry Pi putting these messages out there to AWS IoT and assembling them with Lambda in the back end.
Right.
I think it'd almost be, it would add an element of difficulty to think of the most obfuscated way you could possibly get this done.
Yep, I would agree. We have a question. We talked about SQS about having to pull the queue, and you're totally right. If you have some sort of let's say you have API gateway and Lambda job that's then putting the messages into SQS, you would need to pull the queue. You could actually also, whatever frequency you need to pull that queue, you'd have some advantage of being able to scale out the workers that are pulling the queue. You could also actually build the ability to use CloudWatch metrics. It'll actually tell you how deep is your SQS queue, or how old is the oldest message in the queue that would kind of be have an alarm that could kick off a job that would then consume stuff out of the queue depending on how frequently you have things coming into the queue. So there are some options where you could only take action in the queue when things actually arrive or when they reach a certain threshold. As far as what scale SQS would be considered useful, I think it really would depend on the larger application. I think SQS becomes useful if you want to be able to consume a lot of data, because you've got the SQS managed service being able to bring all that in. And also be able to have maybe multiple workers accessing to be able to process things in batch or in a lot, or if your SQS is kind of your workflow where you're moving things in and out of queues to be able to trigger things to happen. So it may depend on the goals of your larger architecture in that case as far as when you might use SQS, but there's certainly some great examples for that. Joe, another thing that has come up, we talk about kind of these decoupled architectures and being able to take data in is Kinesis. And
I was reading your mind.
Thank you. How would you see Kinesis kind of? I could see some uses of Kinesis fitting into maybe re-architecting this, but what are some things you would see out of Kinesis that might benefit this particular architecture pattern with receiving messages and stuff.
All right. Yeah, absolutely. So first of all, I swear I set up a Kinesis stream to be able to see this. I don't know where I put it. Maybe I put it in a different region, so that was my fault. But Kinesis is really interesting. I really like that the way that the SDK integrates with Kinesis. It just seems really logical to me when I'm putting together when I'm utilizing a queue. When I need to just throw a bunch of stuff into a queue and just grab the items that I need. For some reason, I don't know, it just seems logical to me. But what if we need to make changes on that data as it's coming through? It's a great solution for something like Firehose. As it's coming through, let's say that you have to remove all the dashes from an ID number or something like that. You can just hand off that logic to Firehose and just get it to push through the data. Instead of having to create that logic maybe on an instance within your application, you can just hand it off and have AWS handle it. And then for the love of SQL, right? The Kinesis analytics. I've seen some really cool proof of concept work there, especially in the financial sector. Right. And it's really interesting because when you have a new service and you see new capabilities, you have it in your head some of the things that could be done with those services, and then when a partner and a customer just starts going into, oh, here's how we used it. It's just like, wow, I never even thought of that. Right. It's kind of like the whole basis of the architecture is of AWS, of the platform, is not just for the things that we can think of, for the things that we haven't. Right.
Yeah, I think Kinesis is a pretty cool, useful tool, and I think for our particular example, like we talked about S3 very early on in this particular episode, as far as kind of being a centralized data store, and the fact that Firehose can now take your data into Kinesis and drop it directly into an S3 bucket. If you were taking that approach of I'm just going to receive messages and put them in S3, and I'm going to make sure they're all in one spot, and I'll reassemble them later. Firehose is like a super awesome particular approach, and the cool thing is that Kinesis can do that stuff at any scale. That's the whole thing of real-time streaming. So if you're getting a lot of messages and lots of different parts, get them all into Kinesis at once and just dump them into S3 and sort it all out later. Certainly an awesome approach in a way that you might go about this.
Yeah, and then and there's so many ways to accomplish this too. If you're using just a stream to put that to populate maybe S3, then you could trigger a Lambda function to modify the file once it's in there. Yep. So to get that those dashes out of those IDs, you can use Firehose, you can use Lambda with S3, you can use streams. Yep. There's so many opportunities here. It's just I guess it's limited by creativity and personal preference.
Yep. For our audience, I've thrown another poll into the chat window to kind of find out, be interested in kind of learning what types of caching solutions you're using. We talked about caching, so we're bringing it up specifically. Although there's lots of different things we've talked about today, let's talk specifically about caching. So if you have any thoughts on something you've used for caching, go ahead and take the poll there, and we'd love to see your ideas on that one.
I'm kind of hoping to see like a little flame war between Squid and Varnish.
Okay. We'll see what happens there. One of the other things we didn't really talk about, but we have in our notes here is a little bit of step functions. As far as like how that might lend itself. It's kind of an edge thing to this particular approach with decoupling, but actually I would say it's not. I think step functions is kind of a workflow. It allows you to kind of move different pieces over into different components so that they act independently. I mean, I would say when we talk maybe not about this particular solution with messages, but kind of more of a decoupling approach, which is the theme of our episode today. I think step functions could lend itself well to decoupling because each job would be independent. They don't need to be very heavy, and they can pass off the work to the next job that's specialized and built for that particular piece of work. I mean, would you kind of lend that say that that's definitely a decoupling approach as well?
Yeah, and absolutely, and kind of interestingly, we use step functions as part of the back end of Gameday. When we need to run specific activities at a specific time or anything related to attendee scoring, other activities that are taking place, that's all part of step functions, which operates behind the end user interface being run by something like the API gateway. Can't go into too many details.
No, can't give it all away.
But yeah, we've become big fans on the Gameday development team.
Okay. That's awesome.
And then one of the things I completely there's so many ways to do this that every once in a while some of the most obvious attempts just kind of glaze over your head. And we didn't even bring up like ECS and Docker. I mean, we're running these instances as whole instances right now, but we're using we use ECS and we use containers for whole separate purposes even within Gameday. And so it's one of those things. I told Dave last week, we could dedicate an entire episode, probably the next 3 episodes, just to talk about like different Docker deployments and really cool stuff that's going on. But yeah, I mean, when we think about instances, it's running at the full instance or it's containerizing, and I want to make sure that we brought that one up.
That's cool. Yeah, no, I think that's definitely a way to kind of break things out, and each container is its own little job, and it's focused on its particular thing, and you scale out those tasks.
And since you were talking, and the reason that I remembered was since you were talking about step functions, AWS Batch operates in that similar capacity, to where you can have it's containerized. You have your job that takes place within the container. I mean, it's obviously really directed towards high performance computing, but can operate in a similar fashion. And so I was just thinking of different ways to obfuscate a final answer, like how long can you take to get from point A to point B. I'd like to make this message compilation like over a minute long.
Right, got it. That's very cool. So we're looking at our poll right now. We're still waiting to see if anybody else chimes in, but it's neck and neck between Dynamo and Redis right now as far as caching solutions that might be used today by some of our audience members. So we'll come back and see if that changes at all for us today. I think at this point we've kind of we've hammered home a lot of different options around decoupling. And we've kind of covered a lot of the things we wanted to talk to you guys about today, as well as addressed a few questions from our audience and taken a few ideas in. Joe, do you have any kind of other things around decoupling that you think we haven't covered that you'd like to maybe close out with in the next minute or so?
Yeah, sure. This isn't really, for those listening, I don't want anybody to come up with the idea that this is any kind of new concept. It's gone by different names throughout the years. It was popular as a service-oriented architecture, the SOA architecture, and so it's really been kind of a popular way of pursuing availability, performance throughout the years, and there's really interesting solutions around it. And it's not always obvious, when you come to some pretty complex applications. Years ago I had to decouple a call center software that ran a SIP trunk, SIP server, and it wasn't always obvious how I could get all these individual components apart from each other. But yeah, I mean, it can be a little bit more complex sometimes than others. But yeah, it's typically worth it.
Very cool, very cool. Yeah, I'd quickly summarize from my side. Decoupling is a pretty important architecture pattern, and starting to look at things in smaller chunks and understanding how they can operate as independent entities, but still as part of a larger ecosystem, will give you a lot of flexibility when it comes to being able to pick the right storage solution, pick the right compute and processing solution, being able to scale things independently, being able to support things independently, being able to have something go down and the other parts still remain up. I think when you start looking at decoupling, it gives you all those advantages plus more as far as how your architecture can run optimally. And if you are involved in playing a game day in the future, it'll certainly benefit you of understanding what that decoupling concept means and how you might apply that to the game day or to your real world jobs that you might be doing on AWS. So that's kind of my summary as far as this week goes. As far as what's coming up, I will make a plug. If you happen to be in the New York area and you're looking for something to do tomorrow, we are running a game day at the New York Loft. So please feel free to go to the New York Loft website and check that out and register. We'd love to have you come down. And if you do happen to be down there, let me know. If you were on this episode today, I'd love to say hi and meet you. Joe and I will both be there.
I will throw in a free bracelet to anybody that says that they watched the Twitch episode. So if you come down to the Loft, just say that you watched it. You get either one of these bracelets or another cool.
I'm not sure if you're going to have enough bracelets, Joe.
You won't believe how many I have.
So coming up next week, we've got a couple more episodes to round out the series. Next week, we're going to cover, which is my favorite topic because it's the area I spend most of my time in, and we're going to talk about security. and focus on some of the things that you need to be thinking about when it comes to game day and in general operating on AWS to make sure that you're not only operating a high-performing environment and a decoupled environment, but that you're also running an environment that's secure and you're paying attention to the services and ways you can ensure that you are secure while running on AWS. So going to spend some time and make sure that we have an awesome episode on that next week and give you guys some good information on that. So with that being said, I think we're pretty much wrapped up for the day. I don't have any other things that we can add. Joe, any final thoughts that aren't related to decoupling that you want to share? Or?
No, I mean, just looking at next week, this is your area of expertise, security. Kind of my area of expertise is creating insecure apps. So it should be a good time.
Yeah, so join me next week when we'll be having Joy deploy apps, and then we'll tell you how to make them secure. So thanks, everybody, and have a good week.
Thanks.